So, for our warm-up, we had just talked, and I will recap real briefly for those just coming in, what our approach to this is going to be this morning. Yesterday, we ended up, or our stopping point was looking at this speeding question, the parking ticket. But we had seen that our X values count by 60, 70, 80, 90, 100. So instead of working with X less than 5, as in like under 5 miles over, we said, well, we should maybe try changing our X values to match the scale we see on our X axis. That failed us right here because there's no way that's going to fit on the graph. So this morning, to wrap up this question, it's a very long bell, we're going to come full circle to our original restrictions of less than 5, between 5 and 14 miles over, 14 and 24, and more than 24 miles over. So if you would like to pick out a lined piece of paper to work through that, if you don't have space on the side, we are going to finish this problem successfully. All right? So go ahead and work with this set of points right here, and we will see how that works out. I didn't mean to take your desk if you want to come sit. The snowfall problem, I will just look to see that you tried, and then we will incorporate that into today's notes. Okay, when we substitute in 5, what's my output going to be? Okay, how about when X is, I just picked 0. You could pick 3, 2, 1, whatever you choose. What is it still going to be? 0. So for any constant function, meaning I see no variable here, I just have one constant output, there is no math involved. No matter what X value I choose, the output will be 0. How about for this next piece? When X is 5, what's Y going to be? 120. And when X is 14, what is Y still going to be? 120. Now let's come back to the troublemaker from yesterday. And this time evaluate 15X using X equals 14 and X equals 24 and see what you get. What do we get for 15 times 14? 70. 15 times 14 is what again? 210? So yes, the ordered pair would be 14, comma 210. Are we in better shape with that value? Yes. And then 15 times 24? Okay. And my last constant piece here, when X is 24, what will Y always be? 450. And when X is 30, what is Y again? 450. Constant function. Okay. I still think I have a problem though, because how are you going to graph 5, 0? Because now we have manageable Y values, but I don't see how I can graph 5 on this. Change what? We could. Multiple right answers. Yes. So Olivia said we could add 65 to the X values. Why would that work? Because how do we define x? X is the number of what? Which, the number of miles over the speed limit, and what's the speed limit? So if x is the number of miles over 65, then 5 really means what? 70, 0. And now we have a point that we can graph. Well, let's see. So 70, 0. How about here? So let's graph piece by piece. So 70, 0 would be open or closed? Open. And then 65, 0 would be closed. We established yesterday that this would be array. Next, 5, 120 would become 75, 120. 75, 120, 70. We're adding 65, not 70 to that. Open or closed circle on 70, 120? Closed. Okay. And then 14, 120 would become 79, 120. Where did the 79 come from? Good. So 79, 120, closed. This is looking a lot like yesterday's, right? But let's see if we can now graph this piece that we couldn't graph yesterday. 14, 210 becomes 79, 210. Can I now graph that point? Yes, I can. So 79, 210. And then 15 becomes 80, 360. Which one? Ah, yes. Typo. Okay, so 24 plus 65 becomes 89. So we have 89, 300, 350, 360. Open or closed? Closed. And then our final piece, 24 becomes 89. 30 becomes 95. And now our piecewise function does fit on our graph. 89, 450, 95, 450. Would this be a segment or array? Ray, left or right? Ray, right. Because you're saying anything greater than that many miles over. Yay, we fit. Yeah? Good. Okay, let's talk about the homework question from last night. How did we do with that?
I think I messed up.
Who tried? A+. Let's talk about it. During a 9-hour snowstorm, it snows at a rate of 1 inch per hour for the first 2 hours, at a rate of 2 inches per hour for the next 6 hours, and at a rate of 1 inch per hour for the final hour. Write a piecewise function that gives the depth of snow during the snowstorm. Anybody want to share what they had for their first piece? Lisa?
I had 1x plus 2. X is greater than or equal to 2.
1x. Careful, did it say, so I agree with the 1x because it's 1 inch per hour. If I say plus 2, that's saying that you already had 2 inches on the ground. You had an initial value. So I don't have an initial value right now, but we are going to soon. So keep that in mind. So it's 1 inch per hour for the first 2 hours. So how do I represent for the first 2 hours? X between what and what?
0 and 0.
Mm-hmm. Raise your hand if we had that. Good. If we didn't have that, do we have questions right now?
Right.
Yes.
Would it, if like you were testing this, would you kind of wrong if you just put a 0?
It would be minus a little bit because we have to realize that we can't have negative time. Right? So, just a little bit. Right? Okay. So we have used this first piece, a rate of 1 inch per hour. That's where we got 1x from. For the first 2 hours, that's where between 0 and 2 came from. Next piece, 2 inches per hour for the next 6 hours. Adesola. Because, so the question was, why is it not okay to have hours right here and inches over here? Good question. How is, let's define x. What does x represent? Try again. Try again. Time measured how? Hours. So x is number of hours. What does f of x represent?
The amount of snow.
So let's use how we defined our variables to answer her question. X is my value for hours, yes? And I'm saying between this and this hour. The output over here, my output of the function will be my snowfall. But these restrictions will always be restrictions on the input. So this will always be about hours, hours. My piece, my model is in terms of hours, and the inputs are also with respect to hours. What I get out will be about my snowfall. Great question. Okay, rate of 2 inches per hour. How do I write that as a piece? 2x. But let's come full circle to something she had asked or had indicated about an initial value. If I just say 2x, am I saying there's any snow on the ground? But is there snow on the ground? Yes, there is. So how do I figure out how much snow is on the ground in this next piece of time?
You
Add 2? How'd you get 2?
Because if there's 1 inch of snow per hour and there's 2 hours, then 1 plus 1 is 2.
Very good. So this is the strategy. This counts as notes for today. So in this assignment, grab a highlighter, put this in a box. When we are writing piecewise functions, we do have to account for the initial value that is going to come up in this next segment. So here's our strategy. We are going to take the upper restriction on the previous piece, in this case 2. What is f of 2? So I'm going to give people a chance to look at what I just did. To figure out what initial value is going to go right here, we're going to take our upper restriction on the last piece, which is, in this case, hour 2, and figure out how much snow is on the ground at hour 2. So f of 2 would be 1 times what? 1 times 2 equals 2, which is how I now know this piece is not just 2x, it's 2x plus what? Very good. So let me say it again. Here, we're good with just straight up 1x. There's no snow on the ground. But now 2 hours have gone by, and it's been snowing. So if I just say 2x, and I do not have an initial value, I'm saying there's no snow on the ground. Does that make sense? No, because it's been snowing for 2 hours. So to figure out how much snow is on the ground for this next piece of time, we're going to take that last time that we have, substitute it in, and now I know how much snow is on the ground at the end of hour 2. That becomes the initial value for my next piece. So this next piece applies to what segment of time? Between what hour and what hour? 2 and 8. Very good. Where are they getting 8 from? Next 6 hours. 6 plus 2 is 8. Good job. My final piece says a rate of 1 inch per hour for the final hour. So what's that as a rate? What's mx going to be for that? 1x again. And strategy. How are we going to figure out how much snow is on the ground at the end of hour 8?
Multiply 2x by 8.
We're going to say f of 8 equals what? 2 times 8 plus 2. We are now substituting 8 into this piece. So we get 2 times 8 is 16 plus 2, 18. And this will be between hour what and hour what? 8 and 9. So if last night you had 1x, 2x, and 1x, you were halfway there. We just needed to learn how to account for that initial value for each piece. Are we now good to graph? Go ahead and wrap up your graphs and we'll compare.
Do you care if we put the 1x before the x?
Do not. So the question was, do I care if the 1x is there? If you just write x, I'm totally happy with that. But if you write the 1, I'm totally happy with that too. Let me know if we match. Good? Good? Mm-hmm. Welcome. So what's our total snow accumulation for this entire storm? 27 inches. Very good. Okay. Nice job. Keep the homework out if you would like to use them as notes, because we're going to apply these same concepts to our real-world applications for today. If you notice, our objective has not changed. We are continuing what we did yesterday. Population growth. According to the U.S. Census Bureau, the population of Tucson, Arizona was 45,000 in 1950. From 1950 to 1970, it grew at an average rate of 10.9 thousand people per year. After 1970, the population of Tucson grew at an average rate of 7.5 thousand people per year. Woo, crazy numbers, but not bad. We're going to take it piece by piece. Let's first, see, piece by piece, get it? I know it's Thursday. How are we going to define variables? Let's just first establish what our variables are. Let's use T and P of T, because that's what it's going to ask us to use, so let's use it. T is what? Number of years. Let's establish like a 0 year. What's my 0 year in this question? Everything is since when? Let's do that. So number of years since 1950. And that once I know how much time has gone by, what do I know? What is this whole thing about? Population. Now, we're not talking like single-digit people here. So to make our life a little easier, how can we say we're measuring our population? In thousands. Population in thousands. Okay, very good. We now have a framework for what we're going to do. So it says, find a piecewise linear function, P of T, that gives the population P of Tucson as a function of the year T, which just means P of T. Piece by piece. Who sees my first piece? Looking for my first piece. Cassidy?
45 X is
I'm listening.
X is
So you're right that we're going to start looking here. Let's find a rate first. What's the rate? From 1950 to 1970, what's the rate? We're going to come back to the 45 in a second, but let's establish this first. So how am I going to write that as a rate? And because we define this in thousands, all I need is 10.9 T. Don't have to add any zeros or anything. Now she's picking up on what this 45 is. Y plus 45. Very good. This is my initial population in 1950. So here's my initial value, which makes sense. If we just say 10.9 T, are you saying anybody lives there yet? No, right? Which doesn't make any sense. So in 1950, there were already 45,000 people living there, and the population is increasing at this rate. So how are we going to turn 1950 to 1970 into a restriction? 0 to 20. Where did 0 to 20 come from? Right. 1950. Oops, I want my pen, not the highlighter. 1950 is my 0 year. 1970 is how many years after 1950? 20. So I know that this is T greater than or equal to 0? So let's set this up and then we'll talk signs. Should this be greater than or equal to 0?
No, because
It can't equal 0? Yeah. We are still counting the year 1950. So let's see what happens. If T is 0, what does this entire piece become? 0, and then what's the population? 45. Was that the population in 1950? Yeah. So it's going to be greater than or equal to 0, less than or equal to 20. Yes, because that will get me my 1970 year. Fantastic. Let's go look for our second piece. What do we know next?
that
After 1970,
the population grew 17.5.
17.5?
Or 7.5.
Okay. I think I see my rate. Who sees the rate for this piece? 7.5 T. But now we're back into that situation that we talked about at the start of class. How am I going to figure out where the population left off at? Substituting 20 for T. So P of 20 is going to equal what? 10.9 times 20 plus 45. Let's find that initial value for our next piece. Let me know what you get. We're getting 263? So I have 7.5 T. Yeah. So I'm going to pose a question to you guys. How do I account for the fact that 20 years has gone by for T? Because 20 years has gone by, yes? So it's not really T, it's T 20 years in the future, or I have to subtract 20 years? If 20 years has gone by, that would be plus 20 or minus 20.
Minus 20.
It's past. Let me say that again. 20 years has passed, correct? No, because that would be 20 years in the future.
But it is. It's 20 years from 1950. It's 20 years past. Or 20 years ahead of 1950.
How do I put this? I'm going to write it, and then we're going to talk about it. Okay? So let's write it, and then we'll talk. So I have 7.5. Give me a year. Let's talk 1990. Yes? So 1990 is how many years after 1950? 40. But I need to figure out, if I let T be 40, I'm not talking about the correct year. It needs to be 40 minus this 20 that is already accounted for in another piece. So let me say that again. When you do your initial calculation of 1990 minus 1950, you get 40. But that's an entire 40, where I just need the piece that comes after this 20. So that is why we need to subtract the 20, because this chunk of 20 years is already accounted for. Right? So hence, this will be our calculation. So not only do we need to use this piece to get the initial value, but we have to recognize this chunk of 20 years is accounted for. So I subtract it from whatever t value I actually start with. So let's distribute 7.5. So I'm going to get 7.5t. And then what's 7.5 minus 20? 7.5 times negative 20? Negative 12.5? Do you agree with that?
Oh, wait,
well, that's what I'm asking. So I'm getting crazy answers. Okay, negative 150. So minus 150 plus 263. So my final equation is going to be 7.5t plus 113. And that will be for what piece of time? So this is just as after, right? T greater than 20. And we're done. So now let's use our model. Predict the population of Tucson in 2010. What are we going to do? Well, remember though, so the answer was plug this in, but I need to know how many years after what. So we're going to do 2010 minus 1950, and you get 60. So which piece will we substitute into? Yes. I have one vote for 563. Same? Are we saying 563 people? 563,000. You can either write the word 1,000 or put 3 zeros, whatever makes you happy. Okay, go ahead and work on number 2. Same principle. Yes. Good question. So this says, the question was, why does this say t greater than 20? We're accounting for this final restriction of after 1970. How many years after 1950 is 1970? 20. So after 1970, isn't 1970 is already accounted for up in this first piece. So give me like the first year after 1970. 1971, sure. So t strictly greater than 20. Oh, we didn't do C. Okay, so according to your model, in what year did the population of Tucson reach 100,000? How are we going to figure that out? Look at your restrictions. Ms. J142? Yes. 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 Absolutely. Yep, bye. Okay, 100,000. Thoughts? First one? Work backwards? I now know the population, yes? So we're going to do 100. But which piece? Any other ideas? I like that idea. Very good. So you're both right. She sees that here, what are we saying the initial value is? Which is definitely bigger than 100, right? She sees that when you calculate the population in 1970, you're at 260. So again, way bigger, right? So that means that 100,000 happened somewhere in this first piece. Whichever thinking worked for you, either of those ideas is right. So we're going to say 100 equals 10.9t plus 45. Let's find the year. Who's got a year? What you got, Liz? Rounding to 5? Do we get t equals 5.05? So 5.05 years later really becomes what year? We're not going to go straight to 1956 because 0.05 would be somewhere in this 1955 year. Nice job. Okay, now we get to do number 2. So exciting. According to U.S. Census Bureau, population of Charlotte was 18,000 in 1900. From 1900 to 1950, grew at an average rate of 2.32 thousand people per year. And after 1950, that's supposed to be a comma, the population of Charlotte grew at an average rate of 6.26 thousand people. Give it a shot. Piece by piece, just like we worked on number 1. Yes, I believe 1950. Oh, wait, what's our 0 year now? Careful. 1900, number of years since 1900. And then P of T will still be population in thousands. Do we all agree on the first piece? Oh, of course, yes. That would be so cool. Now, do we all agree on the first piece? Yes. Okay, fantastic. Strategy for the second piece. What are we going to do?
You have to put it in the
Yes. So we're going to take 50. We're going to say P of 50 equals 2.32 times 50 plus 18. Let me know what you get. 134? Who else got 134? Okay. So I know that was the population in that 50th year, but in terms of time, let's first talk rate. What's the rate for the next piece? Okay. I know that's my rate, but in terms of time, we have to account for how many years? 50. So this is going to become 6.26. Good. There we go. Go for it.
Good morning, East Sucker High School. Today is October 6th. Please stand for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Students are reminded to be responsible by being on time and in uniform, to be respectful by treating others with kindness, and to be safe with words and actions. Have a day, next.
I got minus 179. Same? Great. And what's the restriction on this last piece? T is greater than 50. Very good. So you can work on the next those two follow-up questions. Homework, the one on the back and just this one right here. So there's one on the back and then there's no back to this one, right? Still have a couple minutes, so go ahead and wrap up those questions. 3, nice job today. So 1980, which piece are you going to use? Good, the second one. You're welcome. We do 1980 minus 1900. Oh, by the way, the tests are graded and in the grade book. I still have just one that needs to get done for today. So at any point today, you can stop by and take a look at your test.
Can I have a pass to the library for study hall?
Yes. Are you going with her?
Yeah.
The main office needs you real quick.
Okay.
So go with her and then when's your study hall?
8:30.
Okay. Yes, I'll get that for you.
Sorry. I'm just saying I'm over in home. It's happened before.
Okay. Stop by the main office. You're welcome. So that gets me 80, yes. And P of 80 will be 626 times 80, 6.26, times 80 minus 179, and I got 321.8 thousand. Okay, use your model to determine when the population grew to 500,000. Would we use piece 1 or piece 2? Very good. So that will be 500 equals, put like a number 2 under there so you know you're using piece 2. 500 equals 6.26 T minus 179, and then you're off to go find the year. I will be in the library today, D period. If anybody would like to come to the library D period to work on the homework, if you have any questions, I will be there. I will also bring your tests up with me, so if anybody would like to do their tests, you can also do that as well. So if anybody would like library pass, let me know. I will be there D period. Have a great weekend. B period, yes. Let me just wrap this one up real quick.